The lines are parallel. Let's get into this section about parallel lines. How can I determine if lines are parallel or not? I once had a friend in middle school who said it parallel at least once in class, and we all made fun of him after that. But you shouldn't do that. Say it parallel or parallel, whatever, it doesn't matter. Okay, parallel lines. Here's the deal with parallel lines. They never touch. Much like railroad tracks, they go on and on forever without touching. Look at these lines. They go on and on forever without touching. Now, we can find something out about parallel lines. There's a big fact about them that relates to some of the concepts we've been talking about recently in class. Let's look at these lines. Do you notice anything similar about them? We just talked about slope-intercept form, so let's see. Do they have the same y-intercept? No, they have very different y-intercepts. This guy intersects here, this guy intersects here. How about x-intercepts? Do they have the same one? No, they intersect the x-axis in different places. But, oh man, look at this. Down 2 over 1, down 2 over 1, down 2 over 1. This line, down 2 over 1, down 2 over line, down 2 over 1. Oh my goodness, parallel lines have the same slope. Cool, and that's why they never touch, because they keep going down at the same rate. They're never going to touch each other because they're moving at exactly the same rate. It's like if you run right next to somebody forever, you're never actually going to touch them, right? Because neither of you has changed paths. That's how these lines are. Neither of them has changed paths. We can use that for some math. So let's look at example number 1. Are these lines parallel? Why or why not? This line is already in slope-intercept form. Here's my y-intercept, b, so let's plot that, up 6. Here is my slope. Looks like I'm going down 1 over 2. Down 1 over 2, down 1 over 2, down 1 over 2. Okay, so there's my line kind of going right through here. Now, I need to decide, is this line parallel to this line? And I could graph it maybe using intercepts method, but there's an easier way, perhaps easier. Let's look at the slope-intercept form of this equation first. So remember, to convert this to slope-intercept form, I need to isolate y. And to isolate y here, I'm going to subtract 4x. So I have 8y equals negative 4x plus 8. Now I can divide through by 8. So I get y equals, let's see, this fraction reduces to negative 1/2 x, and then 8 over 8 is 1. So let's see, are these slopes the same? They are, they're definitely the same, yes. So since they have the same slope, they are parallel lines. So are the lines parallel? Yes, and they are parallel because look, same slope. So let's write that, the same slope, and the same slope that they have is negative 1/2. Let's just go ahead and graph this line real quick. I have a y-intercept of 1 and a slope of down 1 over 2, down 1 over 2, down 1 over 2. So look, when I graph these lines, yeah, they intersect the y-axis at different points and they have the same slope. So they're going down at the same rate. Very cool. Let's look at another example. Are the lines parallel? Why or why not? So, okay, first of all, what's the slope of this line? Is it 7 because that's the first number you see? No. Remember, the slope is the thing that's multiplying x. When I do y equals mx plus b, I could just as easily do y equals b plus mx. The slope is still the coefficient of x. So what's the coefficient of x here? Well, I don't see a coefficient, so I can put the invisible number 1. 1, or 1 over 1, is my slope. Let's look at this second line and see if it has the same slope. I can do that by converting to slope-intercept form. Isolate the y. So subtract 3x, subtract 3x. I have 3y equals negative 3x plus 8. Divide through by 3. I have y equals, let's see, that's negative 1x plus, this would actually be 2.6 continuing. All right, so this guy has a slope of negative 1. This guy has a slope of positive 1. Are those the same No, they're not the same. If one is positive and one is negative, no, and I can say not the same slope. I know it's 1 in both cases, but one is -1 and one is +1, so not the same slope. And let's just graph these lines real quick. I'll start off by graphing this top line. The slope is 1, the y-intercept, the number that is the constant term without the variable, that's my y-intercept. So I'm starting at 7, I'm going up 1 over 1, up 1 over 1. I could also go down 1, left 1, just to get some points in the opposite direction. Looks like my line is like this. This line now is what I'm graphing. Let's see, y-intercept of 2.6 continuing would be right about there. And I'm going down 1 over 1, down 1 over 1, and it's pretty clear, yeah, these lines intersect. In fact, they're perpendicular, but we'll talk about that later on. Summary. Woo, that was a quick video. Hey, did you know Trump won the election? Anyway, parallel lines, they have equal slope. That's the only thing I need to summarize for you. They have equal slope. So when you're asked if two equations are parallel, you can find their slopes. If they have the same slope, they are parallel. If not, they are not parallel. Thank you for watching. Bye-bye.